You're listening to the True Recovery Podcast, where there's help, there's hope. Hosted by Doc Hugh, a functional medicine doctor with over 20 years of clinical experience helping people recover from chronic long-term health conditions.
Welcome, podcast listeners. This is Dr. Hugh, and you are listening to episode number 3. And today, what I want to do is I want to start a series of mitochondria. Mitochondria is really hot right now in the functional medicine world, and there's a lot of patients that come to me and want to know all about their mitochondria. So today, what we're going to be talking about is exactly that. We're going to be talking about mitochondria, and we're going in depth on exactly what the mitochondria is and how it affects your brain and how you can get better. So one of the things I kind of want to start off is with the fluoroquinolones, the antibiotic that pretty much has damaged tons and tons of people out there. And if you're listening to this podcast, it's probably, you've probably been damaged as well. So one of the things is this drug here, it actually goes after the DNA of the bacteria. Now, way back when we talk about the cell wall and we talk about penicillin, I don't know if you remember that, I'm 48 years old here at the time of this recording, but penicillin was coming from mold, right? So what penicillin did is penicillin attacked the bacteria, the outer cell wall of the bacteria. Now, the new classification of these medications, of fluoroquinolones, like Cipro and Levofloxacin, they work on a whole different mechanism. They actually affect the bacterial DNA. The bacteria have DNA in them. So what happens with this medication is it affects the DNA of the bacteria. When it affects the DNA of the bacteria cannot replicate and reproduce, and this is when the cell actually dies. The bacteria dies. It's because you need the DNA. If you don't have DNA, you actually die. So like the DNA is the life code of our cells. The DNA is what tells our cells what to do. It's the blueprint of how the cell should function. So if you have a medication that can actually kill or actually stop the DNA replication, then that bacteria is going to die. So that's the new medication on these bacteria or on antibiotics, and this is how it really affects the bacteria. Now, the thing is with the human beings, like we're actually talking about human beings, is this affects your mitochondria. Now, what happens within your mitochondria is, just to give you a perspective. So every cell in your body has mitochondria. And I'll be getting to this in a minute, because your mitochondria have DNA in them. So the mitochondria are the power houses of the cell. Now, a lot of things people say, oh, mitochondria, it creates power to the cell. And it does create power to the cell. But more significantly than that, it does lots and lots of other intercellular communications that mitochondria need to be well. We need well mitochondria. Now, what happens is the mitochondria itself has a whole bunch of DNA in them. Now, if you remember back to cell biology, you have the cell itself, and then you have the nucleus, and then the nucleus is where you have all the DNA. Now, what happens if you've ever opened up a golf ball, right? If you've ever cracked open a golf ball, you're going to see basically it's a whole bunch of rubber bands wrapped around to create a golf ball. So when we talk about the nucleus in your body, like the nucleus in your cells, and that's where your DNA is, that nucleus and the DNA is very, very tightly wrapped, just like a golf ball. The golf ball has an outer shell that's very hard, and then you should Google the inside of a golf ball, and you're going to see. If you've never seen the inside of a golf ball, Google it and just see what it is. It's basically a whole bunch of rubber. It's a rubber binder, a huge long rubber binder wrapped around in a ball to create a golf ball, and then they put this plastic shell on it. Now, why is that so significant? Because your DNA within the nucleus is very protective. That white coat, just like the golf ball, is very protective. It's hard for the fluoroquinolones to get into the cell nucleus, penetrate the wall, and affect your actually human DNA. Right? This is the actual human DNA that tells your body who we are and expression of life. Now, one of the things is that if you take the DNA of a cell, of an eyeball, or the DNA of a bone or a hair tissue, you can actually create a whole new you. Right? This is pretty amazing stuff. So that DNA within the cell nucleus is very, very well protective. Now, let's go to your mitochondria. Your mitochondria have a whole bunch of DNA. So, for example, let's say we're going to talk about your nerve cell, A lot of people have neuropathy when they've been floxed. Now, within one single cell, one single nerve cell, you have one nucleus with all your human DNA. And then within that one cell, you have anywhere between 15 and 2,000 mitochondria. Between 15 and 2,000 mitochondria are in each single cell, ladies and gentlemen. That's amazing when you think about how much energy production, how much intercell communication that these mitochondria do between the mitochondria and tell the cell when to die and when to live. The mitochondria does it. It tells the cell when to live and when to die. Now, here's what happens. When you have the fluoroquinolone toxicity, when you've taken these medications, what it does, remember, it goes after the DNA, just like the bacteria. It goes after the DNA and affects the DNA replication of the bacteria, therefore killing the bacteria. Now, research shows evolution, wherever you stand in this whole process, they feel that bacterial DNA and mitochondria, human mitochondria, come from the same genetic line. All right. But my whole point in here is when we talk about mitochondria, your mitochondria has lots and lots of round cylinder DNA, just like a ring. Like if you're married, if you wear a ring. So just imagine that the DNA is like a ring. There's a whole bunch of ring structure DNA that's not protective. They're just floating around. It'd be like if you have a small little rubber band in your mitochondria, and that's the DNA. And that DNA tells the mitochondria how to function and what to do. But here's the kicker thing. That mitochondria is not protected. It's not like the cell nucleus where the human DNA is at. That's not like that. These mitochondria or these DNA molecules, these ring structure DNA in the mitochondria are just hanging out. They don't have a protective coat on them. So what does that mean? What does that mean to you? When you take these antibiotics, it completely destroys your mitochondria because it gets in the mitochondria and then it sees all this DNA replication, right? It sees all the DNA, and it starts to attack that DNA and it affects the DNA. It stops the DNA replication in your mitochondria. Now, it doesn't kill all the DNA. There's like literally hundreds of these little cylinder DNA, these ring structures in your mitochondria. But let's say it only kills half of that mitochondria, or it kills half that DNA in your mitochondria. Well, you're going to have a mitochondria that's not going to function optimally. It's not going to produce energy optimally. It's not going to die, because these mitochondria need to know when to die, right? And they don't know when to die because they have poor cellular signaling when they have weak mitochondria. So this is when you get floxed, when you take antibiotics and your mitochondria get damaged, this can be a global problem. And this is why you go to the doctor and you can have all these weird symptoms, neurological symptoms, GI problems, Achilles tendon problems, brain fog, brain fatigue, depersonalization. All these things can occur to you. Why? Because it actually affects every single cell in your body that has mitochondria. And within the mitochondria, there's hundreds of DNA that are just like really just exposed, right? And that fluoroquinolone, that Cipro or Levoquin, loves fat tissue, and all your cell membranes, all your mitochondria, your cells are all fat. So they just get right into that mitochondria. They see that DNA, they affect the DNA stops functioning. Now, not 100% in every mitochondria, but a percentage stops functioning. That mitochondria starts functioning, and then you have global processes, global problems, and you don't really know what's going on. You go to the doctor, and no one can explain it. And at the end of the day, it's because you've had toxicity, you've had damage, your mitochondria is not functioning correctly. So I have lots and lots of resources out there for you. I'm going to leave some links out here. I have you can go to my YouTube station and hit Dr. Hugh Wegworth. I'll pop up. I have a Facebook group. All the links are down below. I have tons and tons of content out there for you. And at the end of the day, if you're looking for help, you can also just schedule a one-on-one phone consult or a Zoom consult with me. I literally help people at this point all over the world that have chronic conditions, whether it's being floxed, hurt by antibiotics, fibromyalgia, whatever it is, irritable bowel. I'm here to help you. I'm here to give information. So I hope you enjoyed this podcast. Give me a thumbs up, subscribe, and where there's help, there's hope. Take care. This is Dr. Hugh Wegworth. Bye-bye.